Welcome back, Algebra 2 Trig students. Today we're learning 7.3 vectors in the plane. Our central question is, how do I find and use direction angles of a vector? I'm the best TA. This is Vivian.
Okay, so this is take 2 of the video. The other one got messed up. Let's see if this one works. But we'll go ahead and first copy down all of the information that you see in front of you. What we have here is the unit vector u, and it's going to be represented by the component form xy. So pretty much something that we are familiar with by now. The thing that we're introducing today is going to be the angle component of vectors. So thinking back to trig, we always translated xy into cosine and sine. So we're also going to do the same thing here. So component form can also be written as cosine of theta and sine of theta, assuming that it is a unit vector. So once we write it in a linear combination form, which we learned yesterday, cosine theta just goes in front of I, and sine theta goes in front of j. When we're talking about theta in this scenario, we're talking about the direction angle of the vector u. Direction angle refers to the angle that you are away from the zero angle, and you're going to see that later on as we sketch one out. But direction angles are important because when we're talking about vectors, remember we talked about how they have a certain direction that they move in. So direction angles are going to be important in telling us which way we're supposed to be sketching and which way certain things are happening. Finally, what we have here is the vector v. Vector v is going to represent any type of vector, and it's going to be based off of the unit vector multiplied by a magnitude. The magnitude will represent like a scalar. In other words, what we're going to stretch the unit vector by. Okay? So what we're going to start off with is example 1. We're going to find the direction angle of each vector. So make sure that is copied down. Pause if you need to. Let me go ahead and move this away now. What we're going to do is find the direction angle of this unit vector, which is given as 2i minus 5j. Now, if you noticed here in this part of the notes, the unit vector is represented again by cosine of theta and sine of theta. So we're going to be using trig identities to help us find the angle measurement. So with this, what I have here is basically all the information I need in order to figure out what theta is equal to. The first thing I'm going to start off with, though, is actually the graph for this. So let's sketch in a very small coordinate plane. I'm going to go to the right 2 and then down 5. 1, 2, 3, 4, 5. My initial will be at the origin. My terminal will be here at 2, negative 5. So that is my vector with a certain amount of direction. And the direction we're talking about is this big angle right here. Now, since this isn't a special right triangle, I can't determine the angle just as is. I'm going to actually have to use my trig identities to help me figure this out. What I should remember is that tan theta is equal to sine theta over cosine theta. Okay. Now, in terms of the scalar v, it is going to be included in here, but if we have a scalar v on top and a scalar v on bottom, they cancel each other out, so we're really fundamentally looking at sine theta divided by cosine theta. What we're going to do then is, as you see underlined right here, take these two numbers and plug them in. So tan theta is going to actually be calculated as negative 5 over 2. With this, again, I can't really figure it out. I'm going to have to use a calculator. So I'm going to have to do theta equals arctan of negative 5 over 2. Or in other words, tan inverse of negative 5 over 2. If I were to plug that into my calculator, I do get a negative angle. And in this case, it's going to be negative 68.2 degrees. But I don't want to refer to them as negative angles, so I am going to have to add 360 to it. which gives me a direction angle of 291.8 degrees. Okay, so that is the direction angle, the full measurement of this little angle right here. And that's it for example 1. So let's go ahead and now move on to example 2. I'm going to ask you guys to copy down quite a bit because the instructions for this one are pretty specific. So for example 2, let me grab this. Hang on real quick. Alright, with example 2, sorry about that. What we're going to be doing is using the vector's magnitude and the direction angle in order to find the component form of the vector. So find the component form of the vector. Using the magnitude and direction angle. Okay, so with that, what is going to really help us out is actually using a drawing. So I'm going to sketch in real quick. You don't have to make it super accurate because that's actually what we're trying to figure out. So we know our direction angle is going to be 60 degrees. And we know that our vector has a magnitude, in other words, a length of 4. What I should immediately recognize is that this is going to be a special right triangle. This is a 30, 60, 90 triangle. And I'm going to use that triangle relationship in order to figure out the rest of these parts, because I want the x and y in order to get my component form. So thinking about a 30, 60, 90 triangle, I know that the hypotenuse is 2. I know that the measurement across from 30 degrees is half of the hypotenuse, so that's going to be 1, or x. And then across from 60 is going to be radical 3 times the measure across from 30. So half of 4 is 2. The measurement across from 60 then is going to be 2 radical 3. So this point right here is 2 radical 3, which means my component form of this vector is 2 radical 3. Okay, and that's the component of our vector v. Okay, now the final example, example 3. We're going to find the component form once again. But this time we're actually going to combine multiple vectors. So find the component form of the sum of vector u, and vector v. So with this one, Vivian, do you have my book? Thank you. Alright, so find the component form of the sum of vector u and v with direction angles. Theta and theta. Okay, so what's going to be given is that we're going to get the magnitude. So the magnitude of u is going to be 3. Magnitude of v will also be 3. And here are the direction angles. So the direction angle of u, vector u, will be 60 degrees. The direction angle of vector v will be 90 degrees. What we're going to be doing is drawing the sum of these two vectors. And again, the visuals really help out in terms of writing our answers, so that's why I'm going to encourage that you always draw in whatever they tell you to do. The first part, because it's a sum of u and v, I'm going to start off with vector u. So 60 degrees. I'm going to go up for a magnitude of 3. So we'll call that vector u, and we know that the magnitude of it is 3. And then from that point, I'm going to draw in like this imaginary axis, kind of to act as our new 0 line. And from there, I'm going to go 90 degrees also with a length of 3. So 1, 2, 3. And this will represent my vector v. Okay, so this is 90 degrees to that kind of imaginary axis. So from here, what I need to do is find the component form. In other words, how far am I from the origin after I finish off with vector v? The way to do that is, once again, I'm going to have to use triangle relationships. So here, I know that the length was 3, so I'm going to go half of 3 here, and I have 3 over 2. And then across from 60 degrees, it's going to have to be 3 radical 3 over 2. So far I have my x part of the component. That's going to be 3 halves. The y value, though, I've only got part of it so far. This other part, nicely enough, it's just the vector v, so the length itself is just 3. So it's going to be 3 plus 3 radical 3 over 2. Now, if I did want to simplify this, I could combine it so it has a common denominator, which would give me a component form of 3 halves. And then 3 over 2 would be 6, so 6 plus 3 radical 3 all over 2. Okay, and that is it. That combines a bunch of different concepts together with vectors. So a little bit of trig, a little bit of angle measurements, with everything you've learned so far about vectors. If you have any questions, go ahead and write them down. Otherwise, we'll see you tomorrow.